Imagine a quiet December morning, as African-American astronomers turn every eye toward a mysterious visitor from deep space.
This object, known as 3I Atlas, drifts into the inner solar system, carrying a story we still struggle to decode.
For the first time, Webb and Hubble will study the same interstellar traveler together. It's like turning two searchlights onto a figure moving quietly through darkness.
But the first surprise is Atlas suddenly glowing a deep, unnatural blue.
Most objects redden near the sun, yet Atlas does the opposite.
That blue glow hints at temperatures hotter than the sun's surface.
So the question becomes, where is the extra energy coming from? Some suspect an internal heating process powering the glow.
Others think it reveals physics we haven't yet discovered.
But color is just the first layer of this unfolding story.
Chemical readings show a nickel-iron balance resembling human-made alloys. It's like finding a beach stone with machine-perfect edges.
That discovery forced scientists to rethink the object's origins.
Could something non-natural shape an interstellar object this way? Another clue hides in something surprisingly simple: water.
Most comets are loaded with ice, yet Atlas carries barely 4%.
Such dryness is rare for anything arriving from deep space.
It suggests a heated past, or a formation unlike any normal comet. Yet despite lacking water, Atlas forms a massive glowing halo.
This halo stretches nearly 300,000 kilometers wide. Evaporation alone cannot explain something that large and bright. 3 spacecraft confirmed the same strange phenomenon independently. Each observation showed Atlas behaving unlike any comet on record.
So now the question becomes, what exactly are we looking at?
Is this a rare natural oddity shaped by unknown forces? Or is it a new category of interstellar matter, unlike anything studied? Some believe this points toward missing pieces in our physics.
Others quietly wonder if something more intentional is involved.
Not proof, but hints that make the mystery impossible to ignore.
December gives us one chance to measure it before it disappears.
Webb will scan its heat signature for unnatural temperature patterns. Hubble will capture fine details across its rotating outer shell. Together, these telescopes may reveal the source of the blue glow. Every clue we uncover suggests Atlas is far from ordinary. Picture a comet that behaves nothing like a comet at all.
Imagine a metallic core where ice should dominate.
Or a halo so vast,
It challenges the limits of natural evaporation.
Even its temperature breaks the simple rules we teach in school.
Objects near the sun should cool and redden, not heat and turn blue.
Yet Atlas shines defiantly, as if warmed from the inside out.
The mystery is scientific, but it's also deeply philosophical.
What does it mean when something breaks every pattern we rely on? What if our assumptions about interstellar visitors are too narrow? And what if the universe is more inventive than we ever imagined?
For now, we observe a young Caucasian female traveler, leaving more questions than answers.
Its glow is a subtle signal that something unusual is unfolding. Maybe within that glow lies a story we're just beginning to hear.
December's data could reshape how we study interstellar objects.
Or it may reveal Atlas is stranger than any scenario we pictured.
Either way, this encounter will influence future exploration.
Because each anomaly widens the frontier of scientific discovery. And every mystery reminds us how much remains uncharted.
Atlas isn't just passing through, it's rewriting expectations in real time.
Its blue light may be trying to tell us something subtle and important.
For now, we watch and wait for the universe to reveal its truth.
As Atlas continues its journey, we follow the questions it leaves behind.
Imagine holding a thermal model showing Atlas refusing to cool the way natural objects should.
It's submerged. Its temperature remains strangely stable even as sunlight blasts its surface.
It behaves as if wrapped in some hidden heat-resistant layer.
Natural comets don't keep heat. They lose it quickly as they rotate.
Atlas brings that rule, holding warmth like a controlled system.
Stability hints at a structure designed to survive extreme temperatures. Or perhaps we're seeing a type of interstellar crust we've never encountered.
Then comes the brightness, a sudden surge far beyond known Oort cloud comets. Sunlight should erode and dim fragile bodies, not make them brighter.
Yet Atlas brightens, as if fueled by a deeper internal process.
It's like watching an ember glow hotter, even when wind should cool it. This behavior forces astronomers to ask what energy source is at work.
But the anomalies don't end with heat and brightness. They reach into its path.
Interstellar visitors usually plunge in at random angles.
Atlas instead glides in only 5 degrees off the planetary plane. Its smooth path lies almost perfectly along the ecliptic.
That's like a stranger entering a city and choosing the main highway instantly.
Such precision is rare and raises questions about unseen influences.
And then there's the direction, the part no one expected.
Atlas approaches from the same patch of sky as the famous WOW signal.
It's a coincidence, yes, but a striking one that spans 48 years.
No one claims a link, but ignoring it feels premature.
It's like receiving two letters decades apart from the same unknown address.
These parallels add weight to an already puzzling object.
Yet the strangest clue may come not from light, but from radio silence.
Several stations caught faint background noise that shouldn't be there.
It wasn't strong enough to call a signal, but too patterned to ignore. The noise behaved as if shaped by a structured electromagnetic field.
But again, nothing is certain, only unusual.
Imagine hearing a whisper through static without knowing if it's real.
That's the position radio astronomers find themselves in today.
Put together, the clues form a picture that feels incomplete.
Stability, brightness, and trajectory each defy our expectations.
Still, none of this confirms a non-natural origin.
It simply demands we keep our minds open as December approaches.
What if interstellar space holds structures far tougher than ice and dust?
Or what if we're seeing a kind of shell built to survive star heat?
It's speculation, yes, but speculation guided by real data. Whenever nature behaves strangely, it tells us something important.
Atlas might be our chance to watch that message arrive in real time.
It's not about conclusions, but about asking sharper questions.
What shapes a body that controls heat so precisely?
What path leads an interstellar traveler straight onto our planetary plane?
And what causes radio noise that almost forms a rhythm?
These aren't answers. They're invitations to investigate.
Think of Atlas as a riddle, drifting silently through our system.
We have that one brief moment to study it before it leaves again. December's observations may reveal whether it's natural or something else.
Or they may uncover phenomena we never imagined before.
Either way, Atlas forces us to rethink our assumptions.
Challenges the belief that interstellar visitors must follow familiar rules. And it reminds us how much the universe still hides from view.
We may be witnessing a rare event
that future generations will study. For now, we observe, record, and keep every possibility on the table.
Because in mysteries like this, answers often appear when we least expect them.
And until then, Atlas continues forward, carrying secrets we've only begun to uncover.
Imagine watching a comet push its own tail straight into the sun instead of away from it.
Natural comets always shed dust away from sunlight, never toward it.
Atlas behaves as if resisting a powerful solar wind on purpose.
It's like seeing smoke drift into a hurricane instead of being blown away.
Such reversed outgassing forces scientists to rethink known comet physics.
Something is overpowering the sun's push, and no one knows how. Imagine a hidden engine redirecting material exactly where nature forbids. But the strangeness doesn't stop with the backward plume.
Early radar scans reveal a strangely asymmetric reflective shape.
Natural bodies usually reflect radar evenly across their surfaces.
Atlas reflects more like something with uneven or patchwork surfaces.
It resembles engineered structures more than a carved piece of rock.
Radar sees details our eyes can't, and those details raise questions.
Something about Atlas's shape looks unexpectedly intentional.
Yet science demands caution before jumping to dramatic conclusions. Still, the object keeps pushing us toward possibilities we rarely explore.
One possibility is new physics we simply haven't mapped yet.
Another possibility is a natural fluke so rare it defies probability.
The final possibility is a technological origin beyond our understanding. None of these options are comfortable, but all must be examined.
The blue glow deepens the mystery even further.
Blue emission means heat far higher than expected for a small body.
Objects near the sun should redden as they lose energy.
Atlas instead shines bluer, as if fueled from inside.
Thing is keeping it hotter than sunlight alone can achieve.
It behaves like it has an internal energy source, stabilizing its temperature.
Natural bodies cool. They don't regulate heat with precision. But Atlas holds its heat the way controlled systems do.
Imagine a device designed to survive intense stellar environments.
Atlas uses active thermal control. That's revolutionary technology.
Technology far beyond anything humanity can build today.
But extraordinary claims require extraordinary evidence.
Scientists approach this object with careful curiosity, not assumptions. Every new reading pushes us closer to a boundary of the unknown.
The reversed plume hints at forces acting against solar wind pressure.
The blue glow implies internal heat far above natural limits.
Together, they form a puzzle that defies simple explanations. Could nature create something that mimics controlled engineering?
Physics allow inward-flowing plumes under extreme conditions.
Or could Atlas be something entirely outside our current imagination?
These questions are difficult, but avoiding them would be unscientific.
Atlas forces us to confront the limits of what we think we know.
Comets shouldn't push against solar wind, yet Atlas does.
Natural shapes shouldn't reflect radar like uneven panels.
Small bodies shouldn't shine blue in heavy scattering zones. But Atlas keeps breaking rule after rule with quiet defiance. It's as if the universe left us a riddle disguised as a comet. And every new observation deepens the sense of something hidden.
We may be witnessing phenomena we've never seen in cosmic history.
Or perhaps we're watching technology built for journeys across star systems.
If true, its creators mastered environmental control far beyond us.
But until data proves anything, all possibilities remain open. Atlas reminds us that the universe still holds secrets we barely detect. And sometimes those secrets drift right into our solar system. We watch, record, and wait for patterns to reveal themselves. Because one object can change how we understand the cosmos.
And Atlas may be that object, breaking the rules one by one.